am Vaibhav from Vaibhav E-Learning Academy. Today we are going to start a new concept in chemistry, that is mole concept and stoichiometry. Now mole concept. So this mole concept, the main unit of this is mole. We have to learn what is this mole. So starting from mole, we have to learn about a scientist named Avogrado. Now, Avogrado, he made one number which is called Na, or Avogado's number. Now, before moving on to Avogado's number, find it what is mole. So what is mole? Mole concept. So we have to learn about mole. So mostly there are 7 main physical quantities. In that 7 physical quantities, we have length, mass, time, temperature, current, luminous intensity and amount of substance. So here the last unit we have is amount of substance. And what is the unit for this amount of substance? The unit of amount of substance is mole. So what is mole? Mole is just a number. And what is the value of this number? The value of this number is 6.022, somewhere it is written 023 into 10 to the power of 23. This is the value of the number of mole, which is called Avogado's number. So 6.022 into 10 to the power of 23. What is this 6.022 into 10 power 23? For example, you take one unit. For example, you are taking a unit pair. Pair means 2 of anything. A pair of shoes, it means that 2 shoes. A pair of pencils, 2 pencils. Then we have dozen. Dozen means 12. It means a dozen of pen. It means 12 pens. Similarly, mole, or we can say Avogrado number. Now, Na. Mostly Avogado's number, they will write it mostly as Na. Na means number of Avogrado or Avogado's number. So Na or mole, 1 mole of anything. Mole. The value is 6.022 into 10 to the power of 23. It means like 6022 and after that 20 zeros. So 20. That many values. So that is also a number. For example, pair, you give 2, dozen 12. Similarly, a mole or Avogado's number, it means 6.022 into 10 power 23 amount of anything. So this value in real life, this is not feasible. This is not possible, or any value of this in real life. So mostly we use this value in chemistry. In chemistry, why? To calculate the number of atoms or molecules, etc. So this mole is actually a number which is 6.022 into 10 power 23, which we use in chemistry to calculate the number of moles, atoms, molecules, etc. This is the basic idea of what is a mole. So we have to find number of moles. So number of moles. So in mole concept and stoichiometry, there are 3 formulas for number of moles, and in these 3 formulas you can solve mostly any question. Number of moles. The first formula of number of moles is weight by molecular weight. Instead of weight, you can also write mass by molecular mass. In chemistry, mostly in these compounds, weight and mass are equal only. Weight by molecular weight or mass by molecular mass. Then, second formula, number of moles is equals to volume given at STP, volume given at STP by 22.4 liters. So this is the second formula. Number of moles is equals to the volume given at STP by 22.4 liters. And the next formula is number of moles is equals to molecules given or molecules or atoms given by Avogadro's number. So these three are the main formulas. Number of moles is equals to weight by molecular weight. This weight will be given in the question, or you have to find that by molecular weight of the compound. Number of moles is equals to weight by molecular weight. Second formula is number of moles is equals to volume given at STP by 22.4 liters. And the next, number of moles is equals to molecules or atoms given by Avogadro's number. So these three are the main formulas, and one more side formula we have. This is not for number of moles, but this is still important, that molecular weight is equals to 2 into vapor density. What is vapor density? Vapor density which we know mass by volume, dense, how much dense the liquid is, but here it is vapor density. It means the density of the gas. Vapor means gas. So 2 into vapor density. Vapor density is the density of the gas. So these are the three main formulas. Now let us do some questions regarding mole concept, and then we'll move on to stoichiometry. We have to find the number of moles in first question 90 grams of water. Second question 112 liter hydrogen at STP. Then 24 gram of helium, 3.01 into 10 power 24 molecules of carbon dioxide, and 49 gram of H2SO4. We have to find the number of moles. So let us start with the first question. 90 grams of water. Okay. So first of all, what is water? Water is H2O. Dihydrogen monoxide, H2O. Now 90 grams of water, number of moles. So here mass is given. So which formula? Number of moles N is equals to weight by molecular weight. This should be the formula. Weight how much? 90 given by molecular weight. Oxygen is 16 plus hydrogen is 1 into 2, 2, 16, 6, 7, 8, 1, 8, 18. 90 by 18. 18 ones are 18 fives are. So number of moles is equals to 5. So the number of moles in 90 gram of water is 5. 5 moles. This is the answer for the first question. 90 gram of water, number of moles is equals to weight by molecular weight. Weight given is 90 grams. Molecular weight of H2O, oxygen is 16, hydrogen is 1, and there are 2 hydrogens. 16 plus 2, 18, 18. So weight 90 by 18, 18 ones are 18 fives are. Number of moles is equals to 5. This was the first question for number of moles. Now second question, 112 liter of hydrogen at STP. Here the volume is given, 112 liter. So second one, we have to find 112 liter hydrogen at STP. STP in the sense standard temperature and pressure. So 112 liter of hydrogen. So here we have to use N is equals to volume by 22.4. What is the volume given? Volume given is 112 liter divided by 22.4. Why? 22 liter of hydrogen at STP. 112 liter hydrogen at STP. Volume given is 112 liter, and at STP is the standard temperature and volume. So here 22.4 if you multiply into 5. 0.4 into 5. Balance 2, 5 to 10, 12, balance 1. 5 ones are 5, and 5 to the 10, 11, and point. So 112.0. So cancel this by 5. It is equals to 5 moles. 5 moles. So here also the number of moles of 112 liter hydrogen at STP is equals to 5 moles. Let me write it down. 5 moles. So what we did, we used the formula of volume by 22 by 4. Volume given was 112 liter by 22.4. We multiplied by 5 and we got the answer as 5 moles. Now the third question, 24 gram of helium. So here 24 gram, third question, of helium. Now here also mass is given. Mass, so N is equals to weight given, weight by molecular or atomic weight. Here we have atoms, so atomic weight. Atomic weight. So weight is 24 by atomic weight. He, the number of atomic number of helium is 2 and weight is 4. So 24 by 4. 4 ones are 4 6 are. So it is equals to 6 moles. So the number of moles of 24 gram of helium is 6 moles. Here also which formula we used? N is equals to weight by atomic weight. Weight given by atomic weight is 4, which is equals to 6 moles. This was the third question, 24 gram of helium. Next question is 3.01 into 10 to the power 24 molecules of carbon dioxide. So fourth question is 3.01 into 10 to the power of 24 of molecules of carbon dioxide. Now here number of moles equals to molecules by Avogadro's number. Molecules in the sense the molecules given. Here the molecules given are 3.01 into 10 to the power 24 given by Avogadro's number. Avogadro's number 6.02 into 10 power 23. 6.022, but it depends upon the question. Mostly in these kind of questions they will give assume Avogadro's number is equals to 6.02 or 6 into 10 power 23, etc. So here 6.02. So here 1 and 2. It means that, and this 23 ones and 23 1 and balance system, because see here 10 power 23, here 10 power 24. So 24 minus 23 remaining 1. 10 power 1 is equals to 10. So it means that 1 by 2 into 10, which is equals to 0.5 into 10, which is equals to 5 moles. So here this is important. 10 power 24 and Avogadro's number is power 23. So 23 and 24 when you get cancelled, we have the remainder 10. So 1 by 2 into 10, which is equals to 0.5 into 10 or 5. Or else you can even do 1s or 2 5s. Both way, here you get the answer as 5 moles. 5 moles. Now the last question. 49 gram of H2SO4. The question is 49 gram of H2SO4. Fifth question. 49 gram of H2SO4. This is called sulfuric acid. Sulfuric acid. So 49 grams of H2SO4. Here for us the weight is given. So number of moles N is equals to weight by molecular weight. Because this is a compound. This is a molecular weight. So we have to find the compound weight. So weight given is equals to 49 divided by H2SO4. We have to calculate the molecular weight of H2SO4. Molecular weight of sulfur is equals to 32 and hydrogen is equals to 1, oxygen is equals to 16. So to find that will be 1 into 2 plus 32 plus 16 into 4. So it is equals to 2 plus 32 plus 16, 4s are 4, 6 are 24, balance 2 4s are 4, 5, 6, 16, 4s are 64. So here you will get 34, 4, 5, 6, 7, 8, 98. So 49 by molecular weight is 98 of the compound H2SO4. So 49 by 98. 49 ones are 49 twos are, which is equals to 1 by 2 moles, half mole, or 0.5 mole. So here 49 grams of H2SO4 has 0.5 moles. There are 5 questions for the finding the number of moles. First one of 49 gram of water which has 5 moles. Here we use the formula weight by molecular weight. Formula we use this one. And for the second question, here volume was given, so we used volume by 22.4. This formula we used. Here also weight was given, so we used weight by molecular weight. Here we used molecules by molecules by Avogadro's number. And for the last question also we used weight by molecular weight. So with these three formulas only, weight by molecular weight, volume by 22.4 and molecular Avogadro's number, you can find the number of moles in any compound. Let us do some more question to understand the concepts of mole concept. So now we have a question. A gas has mass of 32 gram and it occupies 20 liter at STP. Calculate the molecular mass. So in these kind of question also you have to use the same three formulas. Number of moles is equals to that three formulas we have to use over here also. So first one, what are the values which are given to us? They have given the weight, they have given the volume. So N is equals to number of moles is equals to weight by molecular weight. If you want to find the molecular weight, you need to know the number of moles. So you have been given the volume. So you can use number of moles is equals to volume by 22.4. First we can use that one. Number of moles is equals to volume by 22.4. So volume given is 20 by 22.4. This is the number of moles. Now the gas has a mass of 32 grams. So this was the step number 1. Now second step, calculate the molecular mass. Now number of moles is equals to, second formula is weight by molecular weight. So this is 22.4 and here also 22.4. So weight by molecular weight is equal to number of moles. Now here number of moles we know. It is 20 by 22.4 is equals to, this is the number of moles. Weight given is 32 grams. 32 by molecular weight, we don't know. So let us take this molecular weight as X. So we have to find this X. So we need to use the cross multiplication. So we have to multiply this with this and this with this. So 20 into X is equals to 20X is equals to 32 into 22.4. Then X is equals to 32 into 22.4 divided by 20. This will be your molecular weight. If you want to find this is a division process. This will take some time. So let us solve this. 32 into 22.4 divided by 20. Okay. First by 2 we get 10, 11.2. Then by 2 we get 5, here 16. 16 into 11.2. 11.2 into 16. 6 2s are 12 minus 1, 6 1 6 plus 1 7, 6. And 1 1 2. 2 7 8 9, 6 plus 1 7, 1. 179 and 0.2. So this value we will get 179.2 divided by 5. Now 179.2 divided by 5. So 5 ones are, no, first we'll make it into 10. So we get 1792 divided by 50. Okay. So 50 into 3 minus 150. Here 9, here 2. Again 2. So 50 into 4 minus 50 into 5 we can take. Minus 250, 42 and then 0.420. 5 into 8 minus 400. You get 20 and a decimal, so 4. So 35.84. So X is equals to 35.84 grams. This you will get the molecular weight. So a gas has a mass of 32 grams and it occupies 20 liter at STP. Calculate the molecular mass. First, we use number of moles is equals to volume by 22.4, which is equals to 20 by 22.4. Because first we have given mass and you have been given the volume. First you find the number of moles. Number of moles you got this 20 by 22.4. This is 20 by 22.4. Then number of moles is equals to weight by molecular weight. 20 by 22.4 is equals to 32 by X. Cross multiplication and X value you got 35.84 grams. So the molecular mass of the gas is equals to 35.84 grams. This was the question. Now let us move on to the next question and let us see. So from now onwards, we are going to do some stoichiometric questions. So this is one of the stoichiometric questions. First of all, what is stoichiometry? Stoichiometry means, for example, you have an equation. For example, this equation, CH4 methane plus 2 moles of oxygen gives carbon dioxide plus water. In this is the basic equation. Now, stoichiometry means increasing or decreasing the quantity of the reactant to find the increase or decrease in the quantity of product. It means that, for example, here you have 16 grams. For example, 16 grams will give you some 44 grams of carbon dioxide. So, if instead of 16 you are using 32 grams, then how much will you get? That is called stoichiometry. It means interfering with the correct equation to check what will happen, like what will be the product you will get after interfering the product side and reactant sides. So here we have the question, if 16 gram of methane, this is methane, is burnt, find the mass of carbon dioxide produced. So here, first of all, always I have said that you just use the formula for number of moles for mostly these kind of questions. So this is like a big question. 16 gram of methane is burnt. So there is one logic in chemistry. For example, here CH4. What is the number behind it? No number in the sense 1. Here there is 2. Here there is 1 and here also there is 2. It means that 1 mole, 2 moles, 1 mole and 2 moles. This is what a reaction states. Proof of this is CH4. CH4 mass given, for example, here we are taking this as number of moles is equals to mass given is 16 by molecular mass. Molecular mass of CH4. Carbon is 12, hydrogen is 1. So 12 plus 1 into 4, 4. 12 plus 4 is equals to 16. 16 by 16, 1. Number of moles is 1. So that is why here 1 mole of methane with 2 moles of oxygen gives 1 mole of carbon dioxide and 2 moles of 2H2O, water. 16 gram of methane is burnt. 16 gram of methane, now number of moles is equals to mass given 60 divided by molecular mass 16 is equals to 1. So 1 mole of methane is burnt and find the mass of carbon dioxide produced. So when we are burning 1 mole, how much moles of carbon dioxide is produced? 1 mole of carbon dioxide is produced. So in basic language, 1 mole of CH4 methane gives 1 mole of carbon dioxide. Correct, right? 1 mole CH4 gives 1 mole of carbon dioxide. So we have to find the mass of carbon dioxide produced. So 16 grams is equals to 1 mole. 1 mole gives 1 mole of carbon dioxide. We need to find the mass of carbon dioxide. So here, number of moles is equals to weight by molecular weight we have to use. Number of moles is 1 is equals to weight by molecular weight. We have to find the mass. So let us take X by molecular weight of carbon dioxide. Carbon is equals to 12, oxygen is equals to 16. So here we have CO2 which is equals to 12 plus 16 into 2 which is equals to 12 plus 32 which is equals to 44. 44. So we have to find X. So let us take this as the denominator and cross multiply it. 44 is equals to X. It means that 44 gram. 1 mole of carbon dioxide has 44 grams of carbon dioxide. So the 16 gram of methane is burnt. Find the mass of carbon dioxide produced. So if 16 gram of methane is burnt, then 44 grams of carbon dioxide will be produced. This is what the question states. If you did not understand, wait for the next question and we do more such questions for helping you to understand. This was one of the question. So this is somewhat easy question. Let us move on to the next question. Let us see how to solve those kind of questions. So now we have a question over here. Find the volume of CO2 produced when 50 gram of calcium carbonate is heated. So here calcium carbonate gives calcium oxide plus carbon dioxide. We have to find the volume of CO2 produced. Condition is 50 gram of CaCO3 is heated. So here, check over here. 1 mole of CaCO3 gives us 1 mole of carbon dioxide. Okay, 1 mole gives 1 mole. Find the number of moles when the mass of CaCO3 is 50 grams. So here, number of moles is equals to mass given 50 by molecular mass calcium carbonate. Now here, calcium is equals to 40 carbon is equals to 12 and oxygen is equals to 16. Calculate it. So here CaCO3, right? We have to find CaCO3. It is equals to 40 plus 12 plus 16 into 3. Okay. 40 plus 12 plus 48. This equals to 8, 9, 10, balance 1. 4, 4, 8 plus 1, 9 plus 1, 10, 100 grams. So the molecular weight of calcium carbonate is equals to 100 grams. So 50 by 100. So 0, 0 cancel. 5 by 10 is equals to 0.5 moles. Now we can use this concept. 1 mole of CaCO3 gives 1 mole of CO2. Then 0.5 moles of CaCO3 will give you how many moles of carbon dioxide? This is the question. So you can take the number of moles of carbon dioxide to be X. Then we can do cross multiplication. So 1 mole, right? So X is equals to 0.5 into 1, which is equals to 0.5. So the number of moles of carbon dioxide produced will be 0.5. This we got. But we have to find the volume of CO2. So we have to use the molecules formula. So volume formula. 1 mole of CaCO3 gives 1 mole of CO2. Okay. So now we got the number of moles of carbon dioxide produced when 0.5 moles of calcium carbonate is heated. So when 50 grams of calcium carbonate is heated, 0.5 moles of carbon dioxide will be produced. And we have to find the volume. So number of moles is equals to volume by 22.4. Number of moles is 0.5. 0.5 is equals to let volume be X by 22.4. Again cross multiply. 22.4 into 0.5 is equals to X, and 11.2 is equals to X, because 0.5 in the sense half of 22.4 is equals to 11.2. So the answer is 11.2 liter of CO2. Find the volume of CO2 produced when 50 gram of CaCO3 is heated. CaCO3 gives calcium oxide plus carbon dioxide. 1 mole calcium carbonate gives 1 mole of carbon dioxide. So first find the number of moles. Number of moles, we got 0.5 moles. If 1 mole gives 1 mole, then 0.5 moles will give you how many moles? Cross multiply, you will get 0.5 moles. You know the number of moles, then use volume by 22.4. You get the volume to be 11.2 liters of carbon dioxide. So the volume of carbon dioxide produced when 50 grams of CO3 is heated is 11.2 liter. Let us move on to the last question of the video and then we'll wind up with the session. Let's see. So now this is the last question. Find the mass of carbon dioxide produced when 5.8 gram of butane is burnt. So here C4H10 is butane. So 2 moles of butane plus 13 moles of oxygen gives 8 moles of carbon dioxide plus 10 moles of H2O. So 8 moles in the sense 8 into 10 to the 6.02 into 10 to the power of 23. 8 moles means 8 into Avogrado number. So here find the mass of carbon dioxide produced. So here 2 moles of C4H10 gives us 8 moles of carbon dioxide, right? So first of all we have to find the number of moles if the gram is 5.8, if the weight is 5.8. First, N is equals to weight by molecular weight, 5.8 by molecular weight. 5.8 by molecular weight of C4H10. C4H10, carbon is equals to 12, it is equals to 4 into 12 plus 10 into 1, hydrogen is 1. 12 4s are 48 plus 10, which is equals to 58. So 5.8 by 58. 5.8 by 58. So you will get 5.8 ones are 5.8 tens are. So you will get 1 by 10, which is equals to 0.1 moles. 0.1 mole. Now 2 moles give 8 mole. 2 moles of C4H10 2 moles of C4H10 gives 8 moles of CO2. Then 0.1 mole of C4H10 will give how many moles of CO2? Let us take the number of moles of CO2 produced be x. Cross multiply x into 2. So 2x is equals to 8 into 0.5. Sorry, 0.1. 8 into 0.1. Okay. 2x is equals to 8 into 0.1 is equals to 0.8. Sorry, 0.8. X is equals to 0.8 divided by 2. X is equals to 0.4. So when 0.1 mole of butane is heated, then 0.4 moles of carbon dioxide is produced. We have to find the mass of carbon dioxide. So mass of carbon dioxide, N is equals to weight by molecular weight. You have to find the weight. N is equals to 0.4. 0.4 is equals to weight. Let us take X by molecular weight of carbon dioxide. 44 many times you have done. Then 44 into 0.4 is equals to X. X you have to find is equals to 44 into 0.4. 4 4s are 16, balance 1, 4 4s are 16 plus 1, 17.6. X is equals to 17.6 grams. So the mass of carbon dioxide produced when 5.8 gram of butane is burnt will be 17.6 grams. What we did here is we have the equation 2 moles gives us 8 moles. Number of moles is equals to 5.8 by 58 is equals to 0.1 mole. If 2 moles gives you 8 moles, 0.1 mole will give you how much? We will get 0.4. N is equals to weight by molecular weight, and then we got N as 17.6. So this whole concept what we use was just the 3 formulas. You can do the questions of mole concept and stoichiometric equation just by using the number of moles formula and some logic. So I hope you have enjoyed today's video. If you have enjoyed today's video, do like this video, subscribe to the channel if you are new, press the bell icon, share this video if you find it informative. See you next time in the next video. Thank you.